Whenever we do titration calculations, the volume always has to be in litres. You will be given the concentration of the base. Its volume will be 10 millilitres, which will be 0.01 litres. And the base goes in the conical flask. You'll need to determine the amount in moles of base. C equals N over V, so N equals C times V. For merit, your titer volumes will need to be concordant. This means you'll need to have at least 3 values within a range, meaning the largest minus the smallest of 0.3 or less. Keep the numbers in your calculator. At the end, round to 3 significant figures and include units, the amount being in mole, the volume being in milliliters converted to liters, and the concentration in moles per liter. For example, diluted phakic acid, HFK, was titrated against 10 milliliters of 0.123 moles per liter potassium hydroxide. So the first thing we do is to work out the titer volumes by subtracting the initial reading of the burette from the final reading. So 10.9 minus 0.1 is, of course, 10.8. 21.3 minus 10.9 is 10.4. 31.7 minus 21.3, 10.4. 42.5 minus 31.7, 10.8. 10.6 minus 0.3, 10.3. These 3 are concordant. These 2 we will ignore. So there's 2 ways. Either you can do the calculations in the space below or use the grid that you have to create over the page, and I'll show you how to do both of them. Use the volume of potassium hydroxide used in each titration and known concentration of potassium hydroxide, 0.123 moles per liter, to calculate the amount in moles of potassium hydroxide in the titration flask. So they tell you C equals N over V, so that means N equals CV, which is 0.123 times potassium hydroxide is 10 milliliters, which is 0.1 liters, giving us 0.00123, or on your calculator it might be 123 times 10 to the minus 3 mole. Calculate the average volume of the concordant titers of the diluted phakic acid. So that means 10.4 plus 10.4 plus 10.3 equals, divided by 3, equals 10.37 milliliters, which divided by 1,000 is 0.01037 liters. The balanced equation for the reaction, and that should just be a straight arrow, use the mole ratio. Okay, so we have 1 mole of HFK reacts with 1 mole of KOH. So the amount in mole of potassium hydroxide is the same as the amount in mole of phakic acid. So that will be 0.00123 mole, same as KOH. Use the volume of phakic acid calculated and your answer to question 3 to calculate the concentration of phakic acid. So C equals N over V, which is 0.00123 over 0.01037. This is mole, this is liters, giving us 0.118 0.6, which to three significant figures is 0.119 in unit moles per litre. You can do it that way. You can also use the grid, but you have to draw the grid yourself. Okay, so here I'll have the KOH, here I'll have the phakic acid ratio, concentration in moles per litre, amount in moles, volume in litres. This is 1-to-1. We are told that the concentration of potassium hydroxide is 0.123. There it is there. We're also told that the concentration, that the volume of potassium hydroxide is 10 milliliters, which is 0.01 liters. That goes there. This is the average of the concordant volumes, which is 0.0137. N equals C times V equals 0.123 times 0.01 equals 0.00123. Because these are in the ratio of 1-to-1, this is the same. And then the concentration, C equals N over V, which is equal to 0.00123 over 0.01037, and I'll write the answer down here, 0.119 moles per litre.